Hi everyone, let's try another stoichiometry problem, starting out with atoms this time instead of with grams. But many of the steps are very much the same. So this problem reads, how many atoms of aluminum will react completely with 1.33 times 10 to the 24th atoms of sulfur to produce aluminum sulfide? So again, the first thing we're going to do is make our balanced chemical equation. So we have aluminum is reacting with sulfur, which is also a solid at room temperature, to produce aluminum sulfide. So aluminum is a +3 ion, sulfur is a -2 ion. So if we put those two together, we need to go for the least common multiple, which is a 6. So it's going to be Al2S3. So very similar formula to what we had with aluminum oxide. Okay. All right, so let's balance this. We have 2 aluminums on the right-hand side, so let's put a 2 in front of the aluminum on the left-hand side. We have 3 sulfurs on the right-hand side, so let's put a 3 in front of the sulfur on the left-hand side. So now we have our balanced chemical equation. Now, we're starting off with that many atoms of sulfur. So we're starting off with 1.33 times 10 to the 24th atoms of sulfur. Now we need to change this to moles, and you probably remember from last semester, to go from atoms or particles or molecules to moles, what do you need to use? That's right, Avogadro's number. So there's 6.02 times 10 to the 23rd atoms of sulfur per 1 mole sulfur. Okay, now that we have moles of sulfur, we're going to need a mole ratio. We're going to put moles of sulfur on the bottom, and it's asking how many atoms of aluminum, so let's put moles of aluminum on top. To get the numbers in the mole ratio, we use the coefficients from the balanced chemical equation. So we put a 2 in front of the aluminum and a 3 in front of the sulfur. But it's asking how many atoms of aluminum, so we need to do one more step. Let's put moles of aluminum on the bottom and atoms of aluminum on top. And we know that 1 mole of aluminum is 6.02 times 10 to the 23rd atoms of aluminum. 1 mole of anything is 6.02 times 10 to the 23rd atoms. Let's check our units to see if we got this set up right. Atoms of sulfur cancel out. Moles of sulfur are canceling out. Moles of aluminum are canceling out. And we're left with atoms of aluminum, which is what we want to answer in. Now, you may also notice that to make the math easier, we've got Avogadro's number in the denominator and Avogadro's number in the numerator up top over here. So just to make our calculation easier, we can calculate those, we can cancel out those two as well. So to do our calculation, we do 1.33 times 10 to the 24th times 1 times 2 divided by 3 divided by 1, and when I did this, I ended up with 8.87. Is it 8.87? Yeah, 8.87 times 10 to the 23rd atoms. Now again, it's a good idea to go back and see if the numbers make sense based on the equation, the data you were given. Okay. Now notice when we look at the balanced chemical equation, you're going to need more sulfur atoms than you're going to need aluminum atoms, because we need 3 sulfurs for every 2 aluminums, which means your answer is probably going to be about 2/3 of whatever you started out with in sulfur. And with sulfur, we started out with 1.33 times 10 to the 24th. So we know our answer has to be less than that, and our answer is less than that. Okay? All right, have a great day.